Some of the absolute worst database incidents I've ever investigated, they actually weren't caused by Postgres, they weren't caused by Node.js, and they definitely weren't caused by bad infrastructure. They were caused by developers trusting their ORM way more than their database. And it's not because ORMs are inherently bad, but because they've quietly convinced entire teams that writing SQL has suddenly become someone else's problem. Okay, let's dive into this explainer and unpack exactly how this happens. We're going to start by investigating a bit of a mystery. Picture this scenario. You've got a production database that has been comfortably serving traffic for months. No issues. Then, suddenly, it hits 90% CPU after just one single new feature gets deployed. You panic, you check your dashboards, but your application servers are sitting perfectly idle. Memory looks completely healthy. You literally try everything to fix it. Well, when you start digging into crashes like this, you usually find out pretty fast that the core infrastructure was never actually the bottleneck. It absolutely wasn't a Postgres failure. Postgres was just doing exactly what it was told to do. And spoiler alert, it wasn't a problem with Node.js either. Scaling up your Kubernetes pods didn't help. Cranking up the number of Node.js instances changed absolutely nothing. Throwing Redis in the mix still didn't help. Why? Because the application itself was never the bottleneck. The real culprit was the silent, hidden SQL that literally nobody realized the ORM was generating behind the scenes. Because, think about it, at the end of every single repository method, every entity you write, every clever decorator, and every relation, the database is still just executing plain old SQL. The ORM doesn't change what runs, it only changes who writes it. There is just a massive, massive gap between why we adopt a tool like TypeORM and how it actually operates in the wild. As a developer, you're sitting there looking at these elegant TypeScript classes, clean object references, and super short operations. It feels great. But PostgreSQL literally has zero idea that your code uses TypeScript. It never sees those beautiful decorators. All it sees are massive and sometimes completely inefficient raw SQL queries coming its way. Now, to be totally fair, we get why TypeORM is so incredibly popular, especially for startups. It makes perfect sense. You get way less boilerplate, awesome autocomplete, and a super clean codebase. It lets teams move incredibly fast, which is crucial. So the mistake isn't choosing TypeORM. The mistake is believing that this clean abstraction somehow magically changes the physical laws of how databases work. That brings us to what's essentially the first law of backend engineering. Abstractions hide costs. They don't eliminate them. You can have this incredibly innocent-looking TypeScript code block that's maybe fetching 50 users and their associated orders, right? But underneath that clean code, it can be hiding some massive performance costs. Nothing in the code itself throws a red flag, but if you look at the database, it's telling a totally different story. This is exactly where the infamous N+1 query problem sneaks in. An elegant, one-line relation call in your code can silently trigger a cascade of queries. The first query gets the users, okay, fine, but then every single user triggers another query to load their orders, and then every order triggers another query for products. So what looks like a single database call in your editor turns into literally hundreds of separate network round trips. Multiply that by thousands of requests per second, and suddenly your database is spending way more time just coordinating queries than actually doing useful work. And it gets worse. Even when developers try to do the right thing and eagerly load relations to avoid those N+1 issues, we run into a new problem: overfetching. Your API might literally only need a username to display on the screen, but the ORM acts like a data hoarder. It retrieves every single column by default. It pulls massive text fields, giant JSON blobs, and audit timestamps that you're never even going to look at. Every extra byte has to travel across the network, eat up shared buffers, and just completely waste your server's memory. To put this into perspective, let's think about a seemingly tiny, completely normal query result. Imagine an endpoint that returns just 300 database rows. In the Postgres world, that's practically nothing. That work might finish in a lightning-fast 40 milliseconds. But wait, because of entity hydration and joined relations, those 300 simple rows can absolutely balloon into 8,000 fully instantiated JavaScript objects. You've got constructors executing, relations initializing, metadata attaching. It's the whole shebang. So your database finished its job in 40 milliseconds, but your application burns another 100 milliseconds just allocating memory. This sends your garbage collector into absolute overdrive and severely inflates your latency. Nothing changed on the database side, but your application just became wildly expensive to run. And hey, don't fall into the query builder trap either. A lot of developers assume that if they use a Fluent API, it naturally produces efficient SQL. Yeah, no. You can still easily and accidentally generate these enormous, sprawling joins and completely redundant clauses that totally wreck PostgreSQL's execution plans. When you feed it poor SQL, the database's cardinality estimates get skewed, and the planner might actually choose a terrible join algorithm just because the estimated row counts were completely off. So let's break down exactly how this goes sideways in production. First, you launch a new feature, and you got a nice little bump in traffic. Great, right? But beneath the surface, those hidden N+1 queries and that heavy entity hydration start silently chewing through your memory. Because everything is running sluggishly, your database connections stay occupied for, say, 200 milliseconds instead of 20. New requests start queuing up behind busy workers, and before you even realize what's happening, system throughput violently collapses and terrible latency spreads across your entire application like wildfire. Okay, so how do we actually fix this? What's the secret? Well, the turning point for any backend engineer is when they stop obsessing over how clean their TypeScript looks and instead start asking one simple question: what SQL actually runs? Because production performance isn't judged by how pretty your code is, it's entirely determined by how efficiently Postgres can move your data. This is what separates the veterans from the pack. Experienced teams actually spend their time digging into the physics of the database. When someone proposes a new repository method, they don't just guess if it'll be fast. They inspect PG stat statements, they actually run explain analyze, and they figure out exactly why the planner decided to ignore an index. Because abstractions don't make database physics disappear. They just delay the moment you're forced to understand them. Now, we are absolutely not saying you should throw TypeORM in the trash. Not at all. Mature teams just know exactly when to leverage its incredible productivity and when it's time to roll up their sleeves and drop down to raw SQL. TypeORM is absolutely fantastic for internal dashboards, building MVPs quickly, and simple CRUD apps. But for complex, heavy-duty workloads like financial ledgers, analytics pipelines, or massive bulk processing, moving that computation closer to the data with highly optimized raw SQL is just objectively the better tool for the job. If you take away just one single thing from this explainer, make it this. Before you rush off to master the next hot framework or ORM, you have to learn how your database actually moves data. You've got to start thinking in terms of rows, memory pages, and indexes. Because every page read from a disk, every packet sent over the network, every row lock, those are physical, unavoidable costs. And they exist whether you handwrite the SQL yourself or let an ORM write it for you. At the end of the day, TypeORM didn't ruin those projects. Let's be real, it has accelerated thousands of incredibly successful projects. The true failure was simply forgetting the SQL that the ORM was abstracting away from us. So the next time you write a beautifully elegant one-line piece of code to fetch some data, take a step back and ask yourself, are you building a clean application or a fast one? Because they aren't always the same thing.